Saxon Advanced Mathematics, Lesson 7. I'm dealing with a lot of shadows on my paper today, students, so bear with me. I hope it is not too hard for you to see. Our topic today is a weird one. It's logic. Logic is a branch of quantitative studies, so it's a cousin to mathematics, but it typically doesn't use much in the way of numbers. It's more of taking ideas and trying to apply them in highly logical ways. Logic is a branch of mathematics that helps you see how math and philosophy used to be closely related. We don't think of them as being similar anymore, but they used to be done by the same people. So that's kind of weird, but when you study logic, you can see it a little bit. In logic, we're using what's called inductive reasoning. Inductive reasoning, in simplest terms, can be described as trying to find a rule. We're going to be looking at a series of statements and trying to see how to formulate a rule and then how to apply that rule. It'll make more sense in a minute. That's contrasted to deductive reasoning, which is what we do when we are applying an established rule. Okay, so our focus today is on inductive reasoning, where we're trying to find a rule. The way that we do that is using something called a syllogism. I know, lots of words, they're not going to matter in the long run. I just want you to have an idea of what these words mean so that if you hear them again, it'll make sense. In a syllogism, it's a very structured kind of argument. We have what's called a major premise, and we're going to look at examples of these and you'll be like, oh, I get it now. A major premise, and then we compare that to a minor premise. And then we conclude whether the argument that we're making is valid or not. A major premise is usually a general idea, and then the minor premise is more specific. And then our conclusion usually is, does it make sense that the general rule applies to the specific situation? And we conclude yes or no. Or, as we say in logic land, valid or invalid, okay? One of the things that we stress when we study logic is that the rule doesn't necessarily have to make sense or be true in real life. What? As long as the logic is stated appropriately, it will make sense. Okay, here's a first example. We have a major premise. Ready? All frogs are green. Now that's not necessarily true. I'm pretty sure that there's, poison dart frogs down at the Woodland Park Zoo that are blue, but we're accepting that as our major premise. All frogs are green. Our minor premise is that Henry is a frog. And the conclusion that we're attempting to evaluate is Henry is green. That's our conclusion. And we're trying to determine, is this valid or not? All frogs are green. Henry is a frog. He fits into the group that the rule is about, right? This is a rule about frogs. And Henry is a frog, so this would be a valid conclusion. Again, it doesn't mean that it's necessarily true that all frogs are green in our world, but that is the rule that we were given here, and we're applying that to this. Here's an example that doesn't work. Our major premise is, if it rains, then I will go to town. We're going to talk more about this style of major premise that has the if and the then. We'll talk more about that later, but sometimes a major premise can be stated as an if-then statement. If it's a frog, then it's green. That's an example of how we would do that. But we'll talk more about that in a few minutes. A minor premise is, it did not rain. And so our conclusion that we're being asked to evaluate is, I did not go to town. Now, when we look at that, we see this one's not as clear cut as the first one. If it rains, then I will go to town. But it doesn't say anything about what happens if it doesn't rain, right? So we can't conclude whether you went to town or not. This is a rule that is only about what happens when it rains, but our minor premise tells us it didn't rain. We don't have a rule about what happens when it doesn't rain. We only have a rule that describes what happens when it does rain. So there is not, this does not flow. The major and minor premise do not give us a valid argument. So this is an invalid syllogism. Right? These things are syllogisms. All right, so this one is invalid because the major premise does not address what's happening in the minor premise. I hope that kind of makes intuitive sense to you. Please do not lose any sleep over this lesson. It's all theoretical stuff, and it's a class that you can focus on studying logic. Most of my daughters took the logic class at Edmonds Community College. Called Edmonds College now. They really loved it. They enjoyed it very much, but it really doesn't have anything to do with anything else in life but just logic. So don't worry. Okay, next one. It's example 7.1. It's another syllogism. The major premise, and you don't have to write major and minor, but I'm writing that just to help you remember that's what these are. All normal dogs have 4 legs. There's lots of writing in this lesson. It'll make you miss numbers. The minor premise is that dog has 4 legs. And the conclusion we're asked to evaluate is that dog is a normal dog. To evaluate the conclusion, we look back at the minor premise and see if this fits into the rule or if it is not really a match. All normal dogs. This is a rule about normal dogs. This is a minor premise about dogs with 4 legs. Those don't match. Okay? This is a dog about the condition. It's not a dog about the premise. All normal dogs. If we said, Susie is a normal dog, then we can conclude, yes, she has 4 legs. But it doesn't work in the opposite order. Just because the dog has 4 legs doesn't mean that it's a normal dog. So this is also an invalid conclusion. If you get this sort of common sensey, if my words are confusing but you can see the logic of this, then don't worry about it. Example 7.2. The most important thing is that you can sort of see why some of these are valid and some are invalid. Here's another one. All boys are good. All boys are good. That child is a good child. Major premise, minor premise, and then the conclusion is that child is a boy. And I hope by now you can see here, okay, this makes it this one's so easy that I think is easier to pop into your head. All boys are good. That doesn't say anything about girls, right? It just says that boys are good. That child is a good child. It doesn't say anything about whether that child is a boy. We can't conclude that just because a child is good, it's a boy. It could be a good girl, right? That's possible. So this is an invalid syllogism as well. The homework problems are mostly like this. All chickens have 3 legs. Major premise. Henny Penny is a chicken. That's from the story of Chicken Little. That's our minor. And then our conclusion is Henny Penny has 3 legs. Now, as you're listening to this, you may be thinking, chickens don't have 3 legs. I know, but that illustrates beautifully the point that the major premise doesn't have to be factual. It doesn't have to be right. It's just a question of whether the argument is structured in the appropriate way. And this one is, all chickens have 3 legs. So chickens are the group, not 3-legged objects. It's all chickens are the group. Henny Penny is a chicken. So she fits the group. And so Henny Penny has the same condition as everybody else in the group. This one is valid. Even though you and I know it's patently absurd because chickens don't have 3 legs, the way the argument is structured is accurate. And here comes one more. I'm going to do it on the next page though because we're going to talk about it a little bit more. Those shadows are really bad. We try moving down. Well, it's just the time of day. It's hard not to get shadows on my table, but I'm going to move us, and see if I can improve this situation. Ready? We're going for a ride. Hang on. Better, right? Okay. Just rearranging all my books. Okay, we're going to look at one more syllogism before we add a new crazy word to the topic. This syllogism is about Jim. All non-athletes are vegetarians. Now, we know that's nonsense because being a vegetarian has nothing to do with whether you're an athlete or not. But that's okay. We just accept that as our major premise. Jim is a non-vegetarian. Okay. Therefore, the conclusion states Jim is an athlete. Okay, now this one's really hard to evaluate because not only is Jim not a member of this group, right? This tells us he's a non-vegetarian. This is talking about non-athletes, but we're comparing non-vegetarians and vegetarians. That's really confusing. So there's a technique we can use to kind of rewrite these statements a little bit, just reword them really, not change their meaning, but write them in different words so that we can make a little bit better sense of them. The way that we do that is first to focus on rewriting the major premise as an if-then statement. Okay, so what we're gonna do is we're going to turn our major premise into an if-then. The way that we do that is to write, if a person is a non-athlete, then they are a vegetarian. I'm cutting out little words because life is short. Vegetarian, right? That says the same thing as this. All non-athletes are vegetarian. If a non-athlete, then vegetarian. Okay? Now, once we get our major premise stated as an if-then, we can create what's called a contrapositive. And the way we would do that is to well, let me just show you what it would be. If, let me write it first and then I'll talk about it. The way that we create a contrapositive is we take both parts of the major premise, we state them in a negative, and we reverse the order. And I'm going to explain this a little bit more in just a minute. I'll give you a little formula, but I want you to see it in an example. If a non-athlete, then a vegetarian, we reverse both of them, and we switch the order, and we make both of them the opposite of what they were by using the word non or taking away. So if non-vegetarian, then an athlete, because this one has non, so we take it away. Here we add a non, here we subtract a non, we reverse the order. The contrapositive always equals the original statement, major premise. Okay, so when we create the contrapositive, we're not changing the major premise. It is the same thing. Okay, so if a non-athlete, then vegetarian. If non-vegetarian, then an athlete. This one we can use to evaluate our original thing. So we're using the contrapositive of this original statement. We changed it first into an if-then, then we reversed it. Now I'm using this. If non-vegetarian, then athlete, and I'm comparing it to our minor premise, which is unchanged. Jim is a non-vegetarian. And the conclusion that we're being asked to evaluate in this syllogism is Jim is an athlete. And what we see is that we've now rewritten our major premise in such a way that we can evaluate our minor premise better, because it says if non-vegetarian, then athlete. Jim is a non-vegetarian. Okay, so then that fits, right? He fits this group, so that is true. That's what this says. And now we can more easily conclude this is valid. So when our minor premise and major premise are stated in such a way that we get confused, sometimes it's helpful to write it as a contrapositive, which means first we change it into an if-then, then we flip it, then we compare it, and we are then able to conclude. Okay? These are the rules of logic that allow us to do this. Okay, so that's the contrapositive. Let me write that up here. Okay, this statement is the contrapositive of this major premise. Okay, it's a kind of like a double negative. That's the best way I can think to describe it. right? I have shoes. I don't not have shoes. Those are two statements that mean the same thing, but one's a double negative of the other. It's the same idea, right? So that shows you how that works. Now I'm going to talk about this if-then business again, right? I'm going to go back to that. The sun's gone behind a cloud now and everything's calmed down. So this is converse and inverse. And again, don't worry too much about this. I'm just trying to put ideas in your head that will just live there if this ever comes back into your life. If a normal dog, then 4 legs. This is the if-then version of a major premise that we had in one of the examples. And it was all normal dogs have 4 legs, right? And we changed it into an if-then, all right? What we can do is let P equals the if part of the statement and Q equals the then part of the statement. So what we can write is that the basic premise says, if we have P, then we have Q, right? We proceed from P to Q. If it's a normal dog, then it has 4 legs. This is a way of symbolizing our premise, our major premise, okay? When we do the contrapositive, what we do is we take the negative of both and we reverse the order, right? So that becomes negative Q leads us to negative P. That's what we just talked about. Right? All non-athletes are vegetarians. All non-vegetarians are athletes, is the way that we reverse that, okay? Now I'm going to take these letters and introduce 2 more ideas. What if you take the original premise and you just reverse it without putting the double negatives on? That's called, oh, I ran out of lines. That's called the converse, the opposite. If a normal dog, oh, I should have written legs here, sorry. If a normal dog, then 4 legs. If 4 legs, then a normal dog. The converse isn't always necessarily true, okay? I'll say it again. If a normal dog, then 4 legs, and if we reverse that, as these letters are saying, if 4 legs, then a normal dog. No, that's not true. Because lots of things have 4 legs that aren't normal dogs, right? Okay, so there's the converse, not the shoes, but the statement. And then there's another idea called the inverse. And we describe that as saying, let's take the opposite of P and see if that leads to the opposite of Q. So in our case, it would be if not a normal dog, then not 4 legs. And we can see that that isn't necessarily true either, because if not a normal dog, then it doesn't have 4 legs. Because you could have a not normal dog that only has 1 eye, but still has 4 legs. It's not a normal dog, but it does have 4 legs. So this isn't necessarily true. So this is always true. The contrapositive is always true. And these 2 are not always true. So as you can see, taking the contrapositive of a premise is much more useful than taking the converse or the inverse, because those aren't always true. Now, we're almost done with this lesson, by the way. I just want to say one last thing. What does this have to do with our math? Why are we even talking about this? This is useful if we're talking about geometry. And we're going to be talking more about geometry. We're going to be doing some proofs, which will require a little bit of this kind of thinking, although we're not going to use these words. Let's take a premise that involves geometry. If something is a square, then it has 4 equal sides. That's true, right? A A square has 4 equal sides. Let's create that's the premise, right? Let's create the contrapositive. We'll reverse the second part and say that leads to the reverse of the first part. If not 4 sides, 4 equal sides, then not a square. That's true, right? If it doesn't have 4 equal sides, then it can't be a square. That is true. So again, the contrapositive is always true. Let's see if the converse is true for this statement. For the converse, we just flip them. We don't negate anything. So for this one, which is Q leads to P, we're saying if 4 equal sides, then a square. And that's not true because there's a thing called a rhombus, right? Which is like a square that's been crushed. Pretend mine's perfect. A rhombus has 4 equal sides, but it's not a square because it's missing the right angles. So we see that this one is, this is valid, just as we thought it would be. This is invalid. I should have said always valid and always not always valid. Okay, and then let's experiment with the last one. Minus P leads to minus Q. And so we're saying if not a square, then not 4 equal sides. And again, this isn't true because if something's not a square, it still can have 4 equal sides. Again, our rhombus is the exception to that rule, right? Because a rhombus is not a square, but it does have 4 equal sides. So this one is also, we proved it in this case to be invalid. Okay, so there's how the idea of logic and the geometry that we're doing kind of interface a little bit. John just wants to kind of deepen your thinking and make you more aware of how mathematicians in the past have come up with some of the rules and ideas that we have. The only problems that you're going to do in this lesson are like the examples that we did, where you're given a syllogism and you're asked, well, no, let me take that back. In the problem set, I can see you're given some major premises and you're asked to rewrite them as if-thens. You're also asked to take some statements that are already in if-then, and you're asked to turn them into contrapositives. Remember to use this. To create a contrapositive, you're using the double negative rearrange strategy. So this is what you need to do those problems. And then there are a couple syllogisms as well, where you're asked to decide if it's valid or invalid. And then there's another one where you have to write the contrapositive. So that's the rule for how to create the contrapositive, right? Make it an if, then, and then reverse it according to this pattern. All right, I hope that goes smoothly for you. Like I said, do not sweat lesson 7. It's not that big of a deal. It's just kind of like a good to know situation. Okay, goodbye.